So we built all the parts for the Trammel Toy. The next step is to do an assembly. I want to kind of go over that with you today. This is the example of what the final assembly would look like. And I think that this exploded view will be helpful in figuring out, okay, how do the pieces come together, because they're all labeled with balloons. In Inventor, the first thing I need to do is I need to check one setting that may or may not be turned on the computer that you're sitting on. If I go to Tools and I go to Application Options, I want to make sure that this option is turned on. Place and ground first component at origin. Okay, if it's not checked, go ahead and check it for you and hit Apply. That way, when we bring our first piece in, it's automatically going to be constrained to the origin and is not going to move. So if that's done, excuse me, I'm going to click on Place, and I'm going to select the base plate. It's going to make sense to be the first piece, the one that's grounded, the one that's not going to move. I only need one, so I don't need to bring in another copy of it, and I'll hit OK. Okay. Notice on the browser there's a little pin. A pin simply means this one is grounded, and if I click on it, it's not going to move off of the origin, which is what we want. From there, I'll start bringing in other pieces that I want to constrain to the object. So let's say like a corner guide block. We built one, but there's 4 that go on this drawing, so I'll go ahead and make 4 copies of it. And using constraint, I'll mate the bottom surface here with the top surface of this. Okay, it still moves, so I need more constraints. I want to flush this edge, hit Apply, and then flush the back edge of the corner block and Apply. I should be able to select it when I'm done, and it shouldn't move either, just like the original piece that was grounded, and I can check to make sure that I have enough constraints to do that. So the other 3, excuse me, would be done the same way. I'm going to skip over that and move to the next component. I'm going to bring in the base pins. There's going to be 8 for the entire assembly, but I'll just bring in 2 for this corner block. I'm also going to bring in the base socket head cap screw. Again, there's 8 for the entire thing, but just 2 on this corner block, so I'll just focus on that too. Now for this one, instead of using mate when I do constraint, I'm going to do insert. And the insert allows us to pick a surface and a hole that I want it to go into. Now, obviously I don't want it to stick up like that, so I'll switch my solution to aligned, and it inserts that cylinder inside that hole. I hit Apply, and then I'm done. The nice thing with insert is it's one constraint and you're done. You don't have to do 3 like we did for the corner block. So I'll keep doing that for each of these here, hit Apply. Same with the screws. If I select the top of the screw, the top of the opening, it's going to insert it there, so on and so forth. Okay. So I got all those pieces on there. The next thing is going to be to bring in the slide blocks. There's 2 of them. There's a threaded one, and there's the non-threaded one. Notice that on here I have a midpoint plane turned on. Remember that when we built this original base, to do the mirror for all the holes, we added 2 planes. We turned that off, but we could turn those back on and use those for our constraints. Like if I want the center point of one plane to line up with the other one. So I want to turn them back on for the base plate, and to do that I can double click on a piece within the assembly, and notice that it grays everything else out except for the piece that I double clicked on, and I'm back as if I'm working on a part file. So I can make all the manipulations on this piece within the assembly, which is a nice feature. So I'll go back to the browser and turn the visibility back on for each of the work planes. Okay, so now I'll have that as an option within the assembly. When I'm done with making the changes, I can hit return, and it takes me back into as if I'm working on an assembly file. So that's a nice feature. Any part within the assembly, if you double click on it, it goes back in as if you're working on the part file. Okay. Now I'm going to then constrain this block to the top surface of my plate. Right? So this at the top here, apply. And then I'm going to mate the planes of the two objects and apply. Right? So now those line up along where the plane is. And I'm going to stop at that point. I'm not going to add any more constraints. Okay? I don't want this to not move at all. I want it to be able to slide up and down along this base plate along that axis. So in this case, for these two, we're only going to add 2 constraints rather than 3. We do want it to be able to move in one direction. Do the same thing for this other one here. This surface with the top, apply. This surface with that plane, apply. And again, when I'm done, this should also be able to move along that axis. Okay. So you guys need to do the other 3 corners. You need to add the crank arm and all those other pieces. And they're constrained the same way I did these pieces here. They're basically all going to be inserts. I'm inserting the cylinder or the screw inside the hole, and I can just use the align to make sure that they're flush properly. When I'm completely done, I should have something that looks something like this. Okay, I can check to make sure, okay, these pieces move as it should, right? These should move back and forth. And there's a kind of a neat little trick on how to animate this to have it move on its own. And it's not necessarily required, but I thought you'd want to see it, so I'll show you real quick on how to do that. Right, so the pieces move, which is good. Now let's animate it to make it do it all on its own. To do that, I need to add one more constraint. This will be an angle constraint, and I want to set the angle between this crank arm and the side of the base to 0. So I'll hit the first solution and hit apply. So now the angle between this surface and this one is exactly 0. If I go into the browser, I can right click on that last constraint I just added, the angle one, and go to drive. I'm going to drive the constraint, and I'm going to tell the computer I want to see all the iterations or all the different angles between 0 and let's say 3600. So that would be 10 full revolutions, right? 360 degrees in a circle. I'll hit play, and it's going through all the iterations between 0 and 3600. You can also kind of jazz this up a little bit if you want. You can change the view from orthographic to perspective to make it look a little bit more realistic. We could add shadows, we could add a ground plane. So again, if I go back to my drive constraint, I'm going to reset this and hit play, and it's got a nice little animation of the movement that my piece can do, and it's all on its own. When I'm done, I want to save this assembly so that we can make an exploded view as the next step.